Greetings all, Ferrariman 601 here, in Kerbal Space Program. Completely different change of pace for us today. This is the latest product of many hours of research, development, flight testing, and all sorts of spectacular failures. I call it the Moonshot 3. Yes, none of you would know this, but yeah, of course, I'm a little bit of a Kerbal nut, and I have already achieved a manned lunar landing, but I needed a more powerful vehicle to basically add to my capabilities on the lunar surface. So this is it, the Moonshot 3, derived from my Moonshot series of launch vehicles that I will probably show you in due course. But yes, this is the third incarnation of the series, the first, hopefully, man-rated version of it, as you can see by the command module and launch escape system. No Kerbals on board for this test flight, because it's the first time that we're going to be integrating the manned spacecraft and launch vehicle together, and I don't want to put any undue risk onto Kerbal kind. However, here it is. We have, for our first stage, 16 Space Shuttle-esque solid rocket motors, plus the 4 main engines of the core liquid fuel stage, which is itself the most powerful liquid engine available in Kerbal Space Program. We've got 16 launch gantry systems to brace those solids upon ignition, because they tend to flex pretty dramatically when they first light up. And then we have 6 solids on the, I guess we'll call it the second stage. The first stage core booster still burning at that point, supplemented by a further 6 smaller solids. They ignite together, of course, in midair after the first 16 solids rather, are jettisoned. And these solids here, the smaller ones, will be jettisoned after they burn out. The other solids remain burning, then they're jettisoned. And then we have another set of 8 small solids for the third stage of our boost. This vehicle weighs a ton and a half, to put it lightly, and we need a whole bunch of ass-kicking to get the thing out of the lower bit of the atmosphere. Basically, the first 13,000 meters, most of these solids will be completely expended by that point only. It's a little bit difficult to control, but it works, in theory. The core booster has 3 main propulsion stages, of course, plus the spacecraft, which has its own engine, and all of the accoutrements that you would expect. So, the Moonshot 3, the first man-rated, hopefully, version of this spacecraft, will engage the SAS just to hold us somewhat stable during ascent. We won't be sending it off on any sort of trajectory. We're just going to be seeing how the launch sequences work in terms of staging and all of that. Basically just a big Orion-esque test flight for this thing. Just want to see how it will perform. So we're throttled up, and we are go for ignition. 3, 2, 1. Ignition! We have liftoff. All 16 ground start motors have ignited, and we have good thrust on the core stage. Nominal overheat expected on stage 1. And we're passing through 1,200 meters. We are go at this time. Now, when the ground start solids burn out, they will be jettisoned. We will wait a few seconds for them to fall away from the launch vehicle before igniting the first set of air starts, only because the exhaust from the air starts will damage the ground starts, and in testing that has caused a catastrophic loss of vehicle. So we're going to give them a few seconds to fall away. Once they burn out in about 5 seconds, stand by for burnout of the ground starts. Burnout. And all 16 ground starts have separated. Had a little collision there, all nominal. Ignition on the air starts. Now you notice the air starts will impart a bit of a spin on the launch vehicle. That's okay. Actually, if anything, it adds to latitudinal stability. So we're not going to work too hard on countering that rotation. It'll basically stamp itself out after the first set of air starts separate. Stand by for burnout of set 1 of the air starts. All 6 air starts have separated. Second set still burning nominally. Passing through 11,000. Good countering of that roll by the SAS. And looking for burnout of the second set of air starts. Burnout. And separation. Yeah, that's not good. Not good at all, yeah. Alright, well, we've had a catastrophic failure on the air starts at separation. They took out the first stage of the launcher, and we have lost all control of the launch vehicle. Control focus has moved toward the remaining core engine cluster. And we're on a ballistic trajectory back to the surface of Kerbal for what will undoubtedly be a massive explosion. We had good ignition of the set motors on the second set of the big solids. However, apparently there was a collision of some sort with the first stage of the launcher, and it took out the first stage tanks. So we are gone ballistic here, and we are standing by for impact. We did not get ignition of the third set of solids. And again, we have lost all control over the launch vehicle. Standing by for impact. 6,000 meters and descending rapidly. We look to be clear of any major structures of the Space Center. $2,000. 1,000. If you're wearing headphones, you might want to lower the volume now. Stand by for impact. Believe all components do have impacted at this time. Smaller ones, some ejecta coming back down. Yes. So, the flight results, 2 minutes 9 seconds of flight time. We achieved our failure at 19,329 meters. We were just going supersonic at the time of the failure. 5.8 G max acceleration. That was probably at ignition of the second set of solids, the first air starts. And yes, we see the cause of the failure, separation of stage 11 confirmed, and then one of the SRBs collided into the KS-25 engine cluster. And then we had size 3 large tank was damaged by engine exhaust from set motor 1. So it was one of the Sepatron motors on the first air start solid set that apparently impinged too greatly on the fuel tank and caused the explosion, which took out the first stage of the launcher. And the litany of failures goes on, all happening basically concurrently. And of course we have our impact. Well, that's why we call it testing, and that's why we didn't have any Kerbals on board, because that's not a very good situation to have. We do have a launch escape system, and ideally in that situation it would have fired, bringing the command module away from the launch vehicle and then under a parachute landing, but no Kerbals were harmed in the making of this video. We will go back to the drawing board on that first air start set mechanism, and then we will see how we can progress.